Hi there, my name is Dimitris Haralambidis, and in this video, we will continue my video series on AP Pre-Calculus content, and more precisely, we will continue talking about the end behavior of a polynomial function. Remember that in the exact previous video, and it would be better for all of you if you watch them in the pre-ordered way I have set them. In the exact previous video, I have discussed what it means graphically, the end behavior of a polynomial function. And there I said that in simple terms, the end behavior is where the y values tend at when the x values either go to plus infinity or minus infinity. That was the graphical interpretation. That was the easiest scenario when we are looking at the graph. Now, we want to see how we can actually do it algebraically, which means by operations. All that we could say about it is that it depends on the leading term. And remember that the leading term is the term in a polynomial function that includes the highest exponent. But before we get there, we need to see how we can properly work with infinity. To begin with, since we are talking about polynomial functions and we are talking about powers, about exponents, let's see the powers of infinity. If we have plus infinity to an odd power, that would have been plus infinity. If we have plus infinity to an even power, that would still be plus infinity. However, if we have minus infinity to an even power, that would have been plus infinity. And if we have minus infinity to an odd power, that would have been negative infinity. One could remember that it's basically what would have happened with integers, positives, negatives, if we raise them to even or odd powers. Like in that case, -3, let's say, to the power of something even, -3 squared, -3 to the power of 4, it should have been positive, while -3 to the power of something odd, let's say -3 cubed, -3 to the power of 7, would have been negative. Same thing applies here. The only difference is that the results are always infinities. So let's see some examples. -infinity to the power of 2. It should be plus infinity. Any kind of infinity, either the positive or the negative, raised to an even power, it's always plus. Plus infinity, whether it's raised to an odd or even power, it's always plus infinity. Minus infinity to the power of 4, plus infinity. Plus infinity to the power of 5, plus infinity. Negative infinity to the power of 6, plus infinity. Plus infinity to the power of 7, plus infinity, and so on. Next, we need to see how we can multiply numbers, positives or negatives, with infinities. Positive times plus infinity. We will once again follow the common rules of multiplying numbers as far as their signs are concerned, but the extra thing here is that all of the results are actually infinities. Plus times plus, the result is definitely a plus, plus infinity. Plus times negative infinity, the result plus times minus should be minus, but infinity. Minus times plus infinity, minus times plus, the result should be minus infinity. And finally, minus times minus infinity, minus times minus, it is plus, the result is plus infinity. So once again, we follow the rules we know for the signs when we were multiplying integers, but the results are always infinities. Let's see some examples. Infinity, that stands for plus infinity, times 3 should be plus infinity. Negative infinity times 4 should be negative infinity. 2 times plus infinity should be plus infinity. Negative 5 times infinity should be negative infinity. Infinity times negative 7 should be negative infinity. 8 times negative infinity should be negative infinity. Negative infinity times negative 2 should be plus infinity. And 10 times plus infinity should be plus infinity. Now, let's see how we can apply all these in an exercise. To find the end behavior of a polynomial function, we must just take the leading term and substitute at it plus infinity and minus infinity. Because remember that when we are talking about end behavior, we need to check both ends. Both the right end, which is when x is plus infinity, and both the left end, which is when x is negative infinity. Let's work an example. Find the end behavior of this. 3x to the power of 4 minus 5x cubed plus 2x squared minus 6x plus 9. So, based on what I said earlier, I need to take the leading term. This is the leading term, 3x to the power of 4. And now I need to check at the right end. When x is plus infinity, 3x to the power of 4 becomes 3 times plus infinity to the power of 4, but plus infinity to the power of 4, it's the same as plus infinity, and 3 times plus infinity is equal to plus infinity. So when x tends to plus infinity, y values tend to plus infinity as well, and by using limit notation, we can write that as follows. Limit of f of x when x tends to plus infinity is plus infinity. We are not done yet. We need to check the other end as well, which is when x tends at minus infinity. 3x to the power of 4 will become 3 times negative infinity to the power of 4. No matter of the sign of the infinity, when it's raised to an even power, it should be plus infinity. So 3 times plus infinity, which is plus infinity. So when x tends to negative infinity, the y values tend to plus infinity, and that by using limit notation can be described like limit of f of x when x tends to minus infinity is plus infinity. That is all. Remember that the operations between powers of infinities and multiplications of infinities with real numbers follow the exact same rules as the ones we knew for real numbers. And then remember that if you want to find the end behavior algebraically, you just take the leading term and you move on with substitutions. That is all. In case you have any concerns, in case you have still any questions, don't be shy. Leave them in the comment section below. As always, thank you for watching and thank you for your time.